welcome to this video on volume. Remember to have your notes printed and in front of you to take down all the extra notes and explanations that you'll be seeing in this video and that you will be hearing from me. Alright. Now, at the end of this lesson, you should be able to find the volume and capacity of prisms. You should be able to understand the difference between volume and capacity and understand some properties of solids, concept of capacity, problem solving, classification of solids, calculation of volume, the concept of volume and the difference between that and capacity, and estimate a volume. So this topic requires you to know how to convert units from one to the next. For example, you need to know how to convert centimeters to meters and centimeters squared to meters squared. Now this was covered in a separate lesson, a lesson that was before this one that you should have covered. So I will not be explaining how I'm changing centimeters squared to meters squared, centimeters to meters, etc. You need to know how to do that. Alright. Now let's look at prisms. So prisms are usually 3D solids, right? 3D meaning three-dimensional. The D stands for dimensional, meaning that they have some length, a width, and a height or depth, right? Unlike a 2D object like a square or a circle, 3D objects has height or depth, right? It has length, and 3D objects also has a width. Okay, so we go that way. So we have 3 dimensions that we're looking at. All right, in a square, which is a 2-dimensional, we just have length and we have a height or depth. Okay, so we're looking at 3D objects and we're finding the volume of them. Now with 2D objects, we could only find area. Okay, with 3D objects, we could find surface area as well as the volume, which is the space inside. Right? So let's look at a cube or a square prism. Right? It has all the sides are equal in length. A rectangular prism, we have longer sides and shorter sides. Right? We know what a cylinder is. It's also called a circular prism, and we'll look at the definition of a prism in a bit. We have a triangular prism, a rectangular prism, which is the same as this one. So we could draw it here as a solid, or we could draw it where we could see the hidden lines. And this one is a pentagonal prism. Now, if we were to cut these shapes along its cross-section, a cross-section would be if I were to cut this shape along here, or if I were to cut this shape along there, if I were to cut the cylinder here, if I were to cut the prism across, if I were to cut here across, cut there across, if I were to cut these prisms along the cross section, it will give the same shape as its top and bottom faces. Alright, so I'm going to highlight the top and bottom faces here. This is a square. If I were to cut a slice of this along the cross section, the slice would look square. If I were to cut a slice, this is my face. If I were to cut along here, then the slice that would come off would be the shape of this face. If I were to cut this along this way, this cross section, right, then it would be the shape of this face. Okay, and all would be the same shape. And similarly for the cylinder, the cross section is cutting across this way. All the slices would be circular, right? If I were to cut it lengthwise, just this way, all the shapes would not be the same, right? The ones near the end will be smaller. Okay, so that is not the cross section. The cross section is parallel to the top and the bottom, right? The faces. Alright, so this is how we identify what a prism is. Now a pyramid, all of the 3D shapes that are pyramids, they have one single point at the top. Okay, so this is not a prism, because if I were to cut along here and along here and along this way, all the slices would be different sizes. Okay, they would not be the same. So these here are pyramids. Alright, we're not talking about the volume of pyramids, we're going to talk about the volume of prisms, and this is how we identify what a prism is. So let's talk about what volume is now that we talked about what prisms are. Now we could find volumes of regular shapes and irregular objects. Right, now an irregular 3D object would be like a stone that you find in the yard, alright, so on the road. If you just pick up a stone from anywhere, we want to find the volume of that stone. The best way to do it is we use a Eureka can. Alright, now this is an experiment that you'll be doing in science, right? In integrated science and in physics, if you plan to do the sciences later on. What we do is we have these we have a Eureka can, right, on a table, right, so they're both on a level surface, and we fill the can just below of the bottom of the water spout. Here, we don't want it to overflow, just there. And we have a measuring cylinder at a height lower than the spout. Okay, so the measuring cylinder can rest here as long as it is below the water spout. So when we put our stone in here, so this is my stone, I carefully place in there and not drop it from a height to cause any splashes. Right, it's carefully placed in there. The water in the can will increase, and that water that overflows and goes into the measuring cylinder tells us what the volume of that stone is. So this is how we find the volumes of irregularly shaped objects. Now let's look at finding the volume of a regularly shaped object or objects. And the first object we looked at is a cube. Okay, so we know that a cube has 6 square faces, and unlike a square, it has a length, a breadth or width, and it has a height or a depth. Alright, and this is why we call these shapes 3-dimensional objects. It has 3 dimensions, a length, a width, and a height. Usually, to find the volumes of these regularly shaped objects, there's some formula. Okay, and the formula for the volume of a cube is, and we have the sides here, so let me highlight a side for you. A side would be one of these, right? And we know all the sides are equal in length because a cube is made up of 6 square faces, right? So it's all square, and we're going to call these sides. Alright, so the volume of a cube is actually side times side multiplied by side. Okay, so although it is a length, a width, and a height, specifically for a cube, we're going to call it side multiplied by the side because it's the same thing, right? It's the same length. Or we could say side cubed, okay, because it's the same value, it's the same length, so side cubed. Now another way we could find the volume of a cube, right, is if we were to find the area of one of the faces. Alright, so I'm gonna highlight here one of the faces. Okay, so another formula is area of a face, and multiply it by one of the sides. Okay, so the volume of a cube could also be the area of one face multiplied by the side. Okay, now all the sides are the same length. Remember, this is a cube, so any one of these sides you could multiply by. Alright, so this is another way that you could find the volume of a cube by multiplying the area by one of the sides. Okay, so let's look at an example. Find the volume of a cube with a side of 2 centimeters. So you're going to imagine some cube. Right, so just sketch a cube. And each side is 2 centimeters. Right? Now, because it's a cube, all the sides are the same. Alright, so we should label at least 3 of the sides 2 centimeters. The volume of the cube, and always write your formula. Volume of cube is equal to side times side times side, or side cubed. Now when you're answering your questions, always write your formula. Even though you know it's simply 2 multiplied by 2 multiplied by 2, always put your formulas down. Right? The exam you are preparing to write gives marks for your formula. If there's an error in your calculation, you could get your marks for your formula. Alright? There are some instances where you could get full marks for your question, right? Even though your answer was wrong, because they will be looking at, you know, your formula, you substituted correctly, and maybe there was one little calculation error somewhere. Alright? So writing your statements and answering your questions and your formulas are important. Okay? So our side is 2, and we're going to cube that. Or you could write 2 by 2 multiplied by 2, and our answer is 8. Now our answer, the units that goes with our answer is centimeters cubed. Alright, because this was 2 centimeters by centimeters by centimeters, so it's centimeters cubed. Alright, that's our unit for volume. It's cubed. Alright, whatever this is, this could be meters, this could be millimeters, it must be cubed to represent volume. Alright, because we're multiplying one length 3 times. Alright, so on page 2, we are looking at the volume of a cuboid. A cuboid has rectangular faces. Okay, so this is one long rectangular face here and a shorter rectangular face. Now, unlike a 2-dimensional rectangle, a cuboid has length, a breadth or width, and a height or a depth. Okay, so sometimes you would see the depth of a container or the depth of a tank. It also means the height. Alright, now we use L, capital L, to represent length, a B or a W to represent width or breadth, and H to represent height, or the letter capital D to represent the depth. And the volume, your formula that you need to remember, is your length multiplied by your width or breadth multiplied by your height or your depth. So let's look at an example. Find the volume of a rectangular block of dimensions 2 centimeters, 4 centimeters, and 5 centimeters. Right, so if I were to sketch that block, right, knowing how to draw these shapes are important as well. Right, so if I were to sketch this block, one dimension would be 2 centimeters, one would be 4 centimeters, and one would be 5 centimeters. Usually your longest length tends to be the length, right? and the shorter one tends to be the width or the height. But if it didn't specifically tell you which one is which, we just know that we need to multiply these three lengths. Again, write your formula, volume of the cuboid, or whatever it is in your question. You could say the volume of a rectangular block. You could write the volume of the cuboid, because that's the shape, right? Or you could write the volume of the shape, and length times breadth times height. Substitute correctly. 2 multiplied by 4 multiplied by 5. You could also put 2 centimeters by 4 centimeters by 5 centimeters. Alright. So that is 2 4s are 8 and 8 5s are 40 centimeters cubed. Now let's look at another prism, the triangular prism. So this prism is made up of 2 triangles and 3 rectangular faces. Right, so we could see our triangle here. This is one triangle. This is the other triangle in the back there. Okay, I'm going to shade them in. Okay, so that's one there and this is one here. Now, your rectangular faces make up the rest of the shape, which is the one in front. Right, this one here in front, the one behind. This is the one behind, and the one at the bottom. Okay, so those are the 3 faces. Now, do you remember the formula to find the area of a triangle? So the lesson before this one was to find the area of a triangle. The area of a triangle was a half base by height, right? And not just any old height, the perpendicular height, right? So the area of a triangle is a half of the base by the perpendicular height. Okay, so here let's label our perpendicular height of this triangle. Now remember, we said in the last lesson that the perpendicular height must be perpendicular to the base of your triangle. Okay, so this here is my height. Okay, my base is this. Alright, so the volume of this triangular prism is going to be the half of this base multiplied by this height multiplied by the length. Okay, because this triangle is extruded, or it is stretched all the way down this length. Alright, and make sure on your notes that you label this diagram, right? So that when you're revising, you know where exactly your length is, where your base is, and what your height should look like. Alright, so your formula that you need to remember is the area of the triangular cross section. Right, now this is not a subtraction sign there, right? This is a hyphen, right? Cross section. So it's the area of the triangular cross section. Remember, we talked about the cross section of prisms, right? So the area of this triangle here multiplied by the length. Okay, and that is how we find the volume of a triangular prism. Now, it don't necessarily have to look like this. Alright, example B here at the bottom is an example of this one. And we have example A as well, which is also a triangular prism. So let's find the volumes of these triangular prisms here. Let's identify our base, our perpendicular height, and our length. So here's our triangle. This here is perpendicular. You see that little box there that represents the 90-degree angle. This here is our height. This is our base. because the height is perpendicular to the base. And this here is going to represent our length. Alright, so now that we have our labels on our diagram, we could now find the volume. So volume is equal to a half base by height multiplied by the length. So a half of the base, which is 12, multiplied by the height multiplied by the length. Alright, and that is going to give us 720. Our units is centimeters, and there's 3 lengths being multiplied, so it is centimeters cubed for volume. Let's look at the other shape, the other example, and let's identify our height, base, and length. Now the height here, this is the perpendicular height to the base. This height is 8 centimeters. The base of the triangle is 10, and the length is the 18 centimeters. So again, when you're doing examples, always write your formula. It will help you remember it. Okay, so a half base by height, this is the area of the triangle multiplied by the length. Okay, so we have a half of the base, which is 10, by the height, which is 8, multiplied by 18 centimeters. Right? So you could also pause the video, alright, at any time before I start working these out, and try them yourself. Alright, so you can apply your formula to the question and work it out yourself. Okay, so this here is also 720 centimeters cubed. Alright, so let's look at the volume of compound shapes. So compound shapes meaning that more than one shape are put together to make one complete shape. Alright, so if we look at this one here, it neither looks like a rectangular prism nor a triangular prism. Right, but if we draw this line here, right, we could see it is made up of a triangular prism. So here we have the top shape, which is a triangular prism. And then we have the bottom part, which looks like a rectangular prism. Okay. So how do you think we could find the volume of these two shapes? Well, we find the volume of each and we add them. Alright, so that's a game plan. We're going to find the volume of the triangular prism and then the volume of the rectangular prism. So what do we need to find the volume of a triangular prism? What is the formula? Well, on the last page, we said we need to find the area of the cross section, this face, the triangular face, and then multiply it by the length. Right? What is the length? Let's start with the easier one. What is the length? This length here is going to be the same as that length there. Okay, so this is going to be 18 centimeters. We also need the base. The base is going to be the same length as the base here, which is 12 centimeters. And we need a perpendicular height, which we know is going to be right angles to the base. So it's going to be this little piece here in red. Alright, so that there is going to be my height. Okay, now what is that height? How can we find that height? Now, this 12 centimeters here before is the height from the top to the bottom. Okay, so this entire height is 12 centimeters. Now, we know that this little piece here that I am going to highlight in blue, right, so this little piece here in blue is going to be the same as this height here, which is 8 centimeters. So if this little piece here is 8 centimeters in blue, what is this piece? What is the height? What is this little height of the triangular part alone? It's going to be 12 minus 8 to give me 4. Alright, so my height is going to be 4 centimeters. Alright, so before we could apply our formula, we need to know where our dimensions are. And with compound shapes, you need to look at the shape, look at the sides, and figure out sides that are not shown. So now we can write our formula. The volume of the triangular prism is a half of the base by height by the length. And let's put in our values. A half of the base was 12, the height is 4, and the length is 18. Okay, so our value here is going to be 432 centimeters cubed. And then we're going to add now the volume of the rectangular prism. So the formula for the volume of a rectangular prism was the length by the breadth by the height or the depth. Our length is going to be the longest side, the 18. The breadth is going to be here, or 12. And the height is only going to be of the rectangular part, which is this 8 centimeters here. And this is going to be 1728 centimeters cubed. Okay, so we're not finished there yet. We still need to find the total volume. So we're just going to add these two values here. Alright, so that's 2160 centimeters cubed. Alright, so let's look at number 2. So you could pause these videos, you could pause the video and try the shape, right, at any point during the explanation and try them yourself. Now let's look at number 2. What prisms did we learn that could help us figure out the complete volume of the shape? Well, we could see that if we split this shape here and this shape here, right, we would have 3 shapes. 1, 2, 3. Okay, so let's use letters instead. We're going to use letters instead because they're all the same shape, right? We're going to use A for this one, B for that one, and C. It's just going to make it easier to write your statements. Okay, so to find the complete volume of this, we need the volume of the shape is going to be equal to the volume of shape A plus the volume of shape B plus the volume of shape C. And this shape is, well, these shapes are rectangular prisms. Okay, so this is how we know which formula we're going to use. Now, all of them will have the same formula, length by breadth by height. But we need to find the length and breadth and height of each of them. So let's look at A first. Where is my length of A? This is my length, okay, of A, and it's 20. So I'm going to put that here, 20. Where is my breadth for A? My breadth is this little piece here, okay? That's 2 centimeters. And where is my height? My height is this piece here. Alright, is there a length in the shape for that height? Yeah, that's this here, right? It's the same height as this 10 centimeters. So that is 10 centimeters. Alright, now we're going to add that to the volume of B. Let's look at B. What is the length of B? Now B, the length of B is going down that way. Okay, we can't see it, so we need to use our imagination and our visual skills to imagine the whole length of B going down that way. And that length is the same as the length of A, which is also 20 centimeters. The breadth of B is going to be this little piece here. Alright, now what is that little piece? If we look along here, we see that this entire length here is 12 centimeters. And these two little tiny pieces here that I'm highlighting green are each 2 centimeters, which is the same as these two little lengths here at the bottom. So if this is 2 centimeters and this is 2 centimeters, what is this piece in the middle? And that is for B. So we're just going to subtract 2 plus 2, which is 4 centimeters, and that length in between there of B, that breadth, is going to be 8 centimeters. Okay, so 8 is my breadth. Now we need a height. Let's look for the height. What is the height of that? So let's look carefully. I'm going to use this highlighter here in green. If this here is my 10 and this here is 8, then what is this little piece in red, which is my height of B? My height of B is going to be 10 minus 8 centimeters, which is 2 centimeters. Alright, so my height of B is 2 centimeters. Right, so we need to look carefully at the shape. It's like a game. We give you some of it and we have to find the rest of the dimensions. The answers are right there. You just have to look for it. Right, now the last one, which is the volume of C. Now C is identical to A. Okay, C has the same dimensions as A. It has the length is still going to be 20, the height is going to be 10, and the width is still going to be 2 centimeters. Okay, so we don't need to check over, you can just put it in by 2 by 10. Alright, so we're adding this, and then we're adding this, and then we're going to add this. Alright, so let's add them up. Let's work them out and add them up. So 20 by 2, that's 40, multiplied by 10, that is 40 with a 0, which is 400. Now this is the same shape as that, so I'm going to put 400 there one time. Alright, so 20 by 2, that's 40, 40 multiplied by 8, that's 8 fours, 32 with a 0, right, from that 20, and we're just going to add these up now. That's 1120 centimeters. If you're not sure what it is we're doing, you look back at your question, right? We're doing volume, right? So your answer is 1120 centimeters cubed. Alright, so let us look at part number 3. I'm doing a lot of examples for you, all different shapes as I could find, right? Questions that are going to come for your exam are not going to be simple questions like find the area of one of these objects. It's going to be a compound shape. Okay, so let's look at this and see what is this compound shape made up of. Well, we're seeing something triangular there, so I could draw a line here, and I have two shapes. I have a triangular prism and I have a rectangular prism. Right, so to find the total volume of these two, well, the single compound shape would be to add the volumes of the two. Alright, so pause the video. We did an example like this for number 1. Okay, so you should have been pausing in between each question and taking down your working. Okay, now pause it and try number 3, and then unpause the video and see what your answer is. Alright, so hopefully you tried the question. And then now we're going to look at the answers. So we said that to find the volume of this compound shape, we need the volume of the triangular prism to be added to the volume of the rectangular prism. Alright. Now, do you remember what the volume of a triangular prism is? We need to write our formulas every time. Okay, each time write your formula. A half base by height, which is the area of the triangle, multiplied by the length of it. Okay, now let's identify the length of our triangle. Here, the triangular part here is going to be the area. We're going to find the area of this, and our length is going to be down here. Right, so our length is going to be the length of the entire shape, which is 12 centimeters. Our height must be perpendicular to our base, which is going to be this red line here. That is going to be my height. Of course, we're going to have to do a little more calculations to find that height, right? Now look at my base. My base is also this red line here. And that is the same as this base here. Okay, which is 9 centimeters. We also need our height. Right, so let's calculate that. If the entire length here from the bottom to the top is 15, and this little piece here is 8, then my height for the triangle is going to be 15 minus 8. Okay, that is going to be 7 centimeters. Okay, so let's fill in my a half. My base is 9. My height is 7. And my length is 12. And that's going to give me 378 centimeters cubed. Please, we are finding volume. And we're going to be adding that to the volume of the rectangular prism, which is length times breadth times height. Yep. So, our length is the longest side. It's going to be 12. Our breadth is going to be this piece here, which is the 9 centimeters. and our height is just this piece here, that's not included in the triangle, and that's going to be 8 centimeters. Right, and that is going to be 864 centimeters cubed, and we need to add the 2, and our answer will be in centimeters cubed because we're finding volume. 1242 centimeters cubed as our volume. Okay, so let's look at number 4. Now number 4 looks like an irregular object, but if you look carefully, it is one face, right? One face that is stretched. Okay, so it is one regular face or one particular shape that is stretched along some length. Okay, so in this case, they gave you the area of the cross section, which is the part that I shaded green, and they gave us the length. So they gave us the area and the length. So in this case, we could come up with our own formula for the volume of this shape, and that volume, as we spoke before, is the area of the cross section multiplied by the length, and the area is 42 centimeters squared by the length, which is 32 centimeters, and our volume is going to be in centimeters cubed. 1344 centimeters cubed. Okay. So here we are seeing that volume is always some area multiplied by some length. Okay, and it's still going to be 3 dimensions, even though it's area, because area isn't squared. It's 2 dimensions being multiplied, and then multiplied by a 3rd dimension to give us volume. Okay, so let's look at the volume of a cylinder. A cylinder has 2 identical and parallel circular faces. So we have a cylinder that's standing up. The other circular face that we're not seeing would be the hidden circular face that is resting on the surface. And in this one will be the hidden circular face there that we're not seeing. Okay, so we have 2 circular faces. Now, to find the volume of a cylinder, we're going to do the same thing as we did for the other prisms, which is to find the area of this surface, right, the cross-sectional surface, and then multiply it by its length. In this case here, this is going to be the height. Okay, and if the cylinder is lying down, we will have this piece here being called the length. Okay, in any case, it's going to be the same value. It's just we call it length and height because of the position of the cylinder. Okay, and we have the area here. Right, and then of course the area in this one will be the same circular face, right, with the area of this. Now, do you remember how to find the area of a circle? Right, so the area of a circle, this was in our previous lesson, pi multiplied by the radius squared. Okay, and we remember that our radius starts at the center of the circle and extends to the circumference. Okay, so in this one here, our radius, and then it will extend to the circumference. Okay, in the area here, right, if you have to show the radius, it's going to start at the center and to any point on the circumference. Okay, so I'm going to label this the radius. Right, and we call that R, and here's R, this is the R. Okay, so the volume of a cylinder is simply the area of the cross-sectional circle. Again, this is not a subtraction sign, this is a hyphen, multiplied by the length or height of the cylinder. Right, so pi r squared by length for a cylinder lying on its side, and pi r squared by height for a cylinder standing on its circular base. Alright, so we need to memorize and to learn off that the volume of a cylinder is pi multiplied by r squared by the height. Again, your units will be in cubic units. Right, it will be centimeters squared or meters squared or millimeters squared, and so on. So now we have some examples, and in this example here, this first one, we are seeing two circles. Okay, we have the length of the tube is 20 centimeters, so we could put in that value one time. Right, the length is going to be this dimension here. Right, and that is 20 centimeters. Now there's an inner radius and an outer radius. Now for both of these circles that we're seeing here, the center of the circle is going to be the same for the both of them. Alright, so we're starting at the same center. Now the inner radius is the smaller circle. Okay, so this inner radius here is 3 centimeters. Right? The outer radius is going to be from the same center to the circumference of the outer circle, which is this radius here, and that is 5 centimeters. So we have the radii, the plural of radius, for both of these circles. So how can we find the volume of the cylinder? Right? So the question here is to find the volume. Okay, so the volume we want to find is the volume of the solid. Now the solid is going to be, this is a different color. The solid is going to be all this part here. Right, so it's a hollow tube. We want the volume of the solid. Okay, so we're finding the volume of this. So we have the outer and the inner. So in this case, to find the volume of the solid part, we could take the volume of the outer shape and subtract the volume of the inner. Right? So that's what we're going to do. Now the volume of a cylinder is pi r squared by height, or in this case it's going to be pi r squared by length. So we're going to write our formula: pi multiplied by r squared multiplied by the length in this case. Okay, let's set the length. And it's going to be the same thing here, but a different length, right? So we're going to say the radius of the outer shape, pi by the radius squared of the inner shape multiplied by the same length. The value of pi on your calculator, or you could use 22/7 or 3.14. Now they didn't specify which one to use here. Alright, I will be using the value on my calculator. It's fine if you want to use your calculator for these lessons, because at the end of it all, the exam that you are going to be writing uses calculators, okay, except for the multiple choice papers. So you need to know how to use your scientific calculator from now. And try to stick with the same scientific calculator from Form 1 straight on to Form 5. Alright, the batteries can be replaced. Okay, if they died, always try to have a spare calculator around. Always make sure the calculator is working close to exam time. Alright, so I'm going to be using pi on my calculator. The r, the radius of the outer shape, which is the larger one, is 5 centimeters. And the length is going to be 20. And I'm going to subtract the value of the inner volume, which is pi. The radius here is 3 and the length is the same, 20. Now make sure you square your radius, okay? That needs to be squared. Alright, so I have 500 pi. I'm going to leave pi there because pi could be whatever you choose it to be, which one of these here. Alright, so the answer will vary. Alright, I'm leaving pi in the answer. So in the other case here, we have the radius being 3, and that is going to be 180 pi. Alright, so 500 minus 180 is going to give me 320 pi. Okay, so the answer will vary slightly if you want to use 22/7 or 3.14 or the value of pi on your calculator. Don't forget your units, centimeters cubed, because we're talking about volumes. Now let's look at finding the volume of a half cylinder. So the length of the cylinder is 16 centimeters. Again, the length is going to be, you could use this side here, 16 centimeters, and the radius is 4 centimeters. Now the radius is going to start from the center and towards the circumference of the circle. And our radius is 4 centimeters. Right? R is equal to that. So let's find the volume. Now this is half of this cylinder. Okay, so the volume here is going to be a half of the volume of a cylinder. So it's a half of the pi r squared multiplied by the height, or in this case they said it's the length. Right, so we use L. So it's a half of pi multiplied by my radius squared, which is 4 squared, multiplied by the length, which is 16. Right, and I'm going to leave my answer in pi again because it will vary according to what you choose to use as your pi. Right, so I have 128 multiplied by pi. My units are going to be centimeters cubed because it's volume we're finding. Alright, so simple enough. You just need to be careful at what you just need to be careful about what they're asking you to find. Alright, so in this case it was the volume of the solid, right, not the hollow part, and here it was half of a cylinder. Right, so we have some other examples here. let's look at number 3. So number 3, we have a composite shape, right? A compound shape. We're seeing a half of a cylinder plus a rectangular prism. So here we have half of a cylinder and a rectangular prism. Alright, so you have some experience with composite shapes already. So what I want you to do is pause the video and try to find the volume of this shape. We already did an example with half of a cylinder, and we already did examples with rectangular prisms, and we did examples with composite shapes. So you pause the video, put in your lengths, put in your values into your diagram, and work it out, and then come back and unpause and view the solution. Okay, so hopefully you paused and you are ready to look at the solution now. So to find the volume of this composite shape, we are going to add both volumes. Okay, volume of that and the volume of this. So we said that the half of a cylinder is going to be a half of pi r squared by, and we have a length, right? A length, because it's one of these cylinders that's lying down. So we have a length. And then we're going to add that value that we find to the volume of a rectangular prism, which we know is length by breadth or width by height. So let's find these values. The length is 6.2 centimeters. Alright, now this 6.2 is the length for the rectangular prism and for the circular, for the cylinder. Alright, 6.2 centimeters. Now the cross section consists of a square. Right, so this is a square, the torus, this is a square, and of side 2 centimeters. So if one side is 2 centimeters, then all the sides is 2 centimeters. Now it's not a cube, because we are seeing here that the length is 6.2 centimeters, which makes this a rectangular prism. Okay, it just happens to have a square cross-sectional area. So let's find the values of these now. Now we are missing a radius. What can be our radius? How can we find the radius? We know that the radius starts from the center and extends towards the circumference. Now if this is a radius, it means that this is also a radius, and also this and this. Alright, so a radius here, radius there, and there, and there. Okay, now we know that the diameter here is the same as the side of a square. So if the diameter is equal to 2 centimeters, and in our previous lesson we know that the radius is a half of the diameter, it means that our radius here is a half of 2, which is equal to 1 centimeter. Alright, so our radius here is 1 centimeter. So let's put in our values. A half of pi multiplied by 1 squared multiplied by the length, which is 6.2 centimeters. And that is going to be equal to 3.1 pi centimeters cubed, because it's volume. And our length is 6.2 multiplied by the breadth, which is 2, and the height, which is also 2 centimeters, because this is a square. So that's 6.2 by 4, 24.8 centimeters cubed. Now that's not the complete answer. The answer is going to be the sum of those two. So it's the sum of this one and the sum of that. So when we add those two together, we will get, right, so the total volume is equal to 27.9 centimeters cubed. Let's take a look at number 4. We have a disk of radius 9 centimeters. So let's put in that value. Again, we're going to start at the center of the circle and extend towards the circumference to find our radius. That's r, and r is equal to 9 centimeters. The thickness is 0.8 centimeters. Alright? So here we're not seeing height or length, but we're seeing t for thickness. Alright, so our thickness here is going to be our height or our length, and it is 0.8 centimeters. Alright, it's still a cylinder, right? A very thin cylinder. So the volume is still going to be pi r squared by, in this case, we're going to say t for thickness. Alright, so that's pi multiplied by 9 squared multiplied by 0.8. And that would give me 64.8 centimeters cubed. Alright, so I left out pi, right? I was trying to not use pi. If you had noticed that, yes, I didn't include the pi here, right? So pi should be here. Let me just correct this, right? I'm leaving pi there because you could use one of the values from before, right? 22 over 7, or you could use 3.14 or the value directly on your calculator. Alright, so pi, right, so this here is 27.9 multiplied by pi. Alright, the value will change depending on what you use as your pi. So for number 4, the volume is 64.8 pi centimeters cubed. Now number 5, don't let number 5 scare you. Alright, we've seen this shape before in 2 dimensions. Alright, I'm going to highlight that shape for you. Alright, what is this shape called? We did this in a previous lesson. Alright, the opposite sides are parallel. It's a parallelogram. We know how to find the area of a parallelogram. To find the volume, it's just a parallelogram that's been stretched or extruded with some length. So can you guess how we could find the volume of this based on what we've been doing so far? Alright, so we have some questions here to answer. What name do we give to the shape of the cross section? We said it's a parallelogram. Okay. And find the area of the cross section. So we're going to find the area of this parallelogram. Now what do we need to find the area of this? From our last lesson, okay, how do we find the area of the parallelogram? Right, so the area of the parallelogram, or the cross section in this case, is base multiplied by the perpendicular height. Okay, so my base is, now if we look closely, we need our base to be the side that is perpendicular to the height. Now the height is this 4 centimeters here. I'm going to label that height. And the base is going to be either this side here or this side, right? We had enough practice with finding areas of parallelograms before. Now it's not the 5 centimeter because the 5 is not perpendicular to this 4 centimeters here. So we're seeing this 7 centimeters there, and that is going to be the same length of this one and this one. So my base is 7 centimeters and my height is 4 centimeters. So my area is 28 centimeters squared, right? We're finding area here. So now we need to find the volume. The volume is going to be the area of the cross section Alright, so I joined the word cross section there, multiplied by they gave us a length. So that is the 28 centimeters squared multiplied by the length, which is 10 centimeters. So my volume is 280 centimeters cubed. Okay, so we need to remember that the volume is just simply of prisms. It's just the area of the cross section multiplied by the length or the height of the solid. So now let's talk about capacity. Now liquids take the shape of the container they are in. So this is a science fact that you need to know. Right? If we pour liquid into a heart-shaped container, it's going to fill that heart shape. If we pour it into a square-shaped container, it's going to take the shape of that square. So when we buy things like a pack of juice or a bottle of soft drink, the external measurements or the volume of the container it is in is not as important as the capacity of the bottle or the container. So that means if we buy a juice box, we don't care how big that juice box is, right? Because we're not eating the juice box. All we care about is the capacity or the amount of liquid that is in that juice box. Alright, so the capacity here, right, is the amount that it is holding. And we care about how much the bottle can hold. Okay, so all these pieces here that is yellow could be a piece of the box itself, right? A solid piece of the box. We don't care about the external measurements. We care about the capacity, how much liquid this box could hold, right? Or the bottle or whatever the container is. So in the science subjects, we use a measuring cylinder to measure the volume of liquids, and the units are called cubic centimeters, right? It could be written as cc or centimeters cubed, right? It's the same thing like what we did for volume, right? So volume is more used for solids and capacity is more used for containers that hold liquids. So the unit of capacity is the liter, right? We don't usually use cubic centimeters, although 1 milliliter is approximately equal to 1 cubic centimeter. Okay, 1 liter is equal to 1,000 cubic centimeters, and 1,000 liters is equal to 1 meter cube. Right? Now, milliliters, centiliters, and liters are what we usually use to represent capacity. Okay, but as we're seeing here, 1 milliliter could also mean 1 cubic centimeter. So with our previous lessons, we did a little conversion like this. How do we change milliliters to centiliters? And how do we change centiliters to liters? and vice versa. How do we change liters to centiliters? And how do we change centiliters to milliliters? So we're changing a small amount to a large amount. We are going to divide by 10. So 10 milliliters in a centiliter. And we are going to divide centiliters. We're going to change centiliters to liters. We are going to divide by 100. Okay. And to change liters to centiliters, we will do the opposite and multiply by 100. And then the centiliters to milliliters, we will multiply that value by 10. Okay, so this is the conversion here with liters for capacity. Right, so let's look at some examples. Right, and I just have 2 examples for you. And then we're done with this topic for now. Right, we will revisit this topic again later on. So let's look at example 1. What is the capacity in liters of a water tank built in the form of a cuboid with a base area of 2 meters squared and a height of 1 meter? So let's put in our values. We have a base area. Right, my base area is going to be this entire shaded region here. Okay, so my area is 2 meters squared. My height, they said my height is, which is this line here. Right, my height here is 1 meter, and we need to find the capacity. Now, it is a cuboid. We will first find the volume of this cuboid. Right, so the volume of the cuboid is length times breadth times height, or we said the area of the base by the height or length, right? But in this case, they give us the height. So it's 2 meters squared multiplied by 1 meter, which will give me 2 meters cubed. Alright. Now, they want the answer in liters because, as we said, capacity is measured in liters. So, go back to your conversion here. How many meters cubed will give me how many liters? So here we're seeing 1 meter cube is equal to 1,000 liters. Okay, so then that means 2 meters cubed is going to give me 2 multiplied by 1,000, which is 2,000 liters. Okay, L-I-T-R-E-S. When we're giving capacity, when the question asks for capacity, we usually put it in liters or milliliters or centiliters. Alright, always look for what they're asking you, what unit they're asking you for, and convert it. Now let's look at example 2, part A. Calculate the volume of a swimming pool with base area of 400 meters squared and a height of 2 meters. So a swimming pool, right, we have a base area and a height. Now, they didn't tell us what shape the swimming pool is. We assume it's going to be rectangular, or it could be circular. Now, they didn't say, but it doesn't matter because we know we're going to find the volume by multiplying the base area by the height. Right, so my base area is 400 meters squared multiplied by 2 meters, which is going to give me 800 meters cubed. Part B, how many liters of water, so they're asking for the capacity, would be needed to fill it. So we said 1 meter cubed is equal to 1,000 liters. So 800 meters cubed is going to be 800 by 1,000, which is 8 with 1, 2, 3, 4, 5 zeros behind it. Right? Liters. Alright, and that brings us to the end of this lesson. And please make sure that you have all your notes filled in on your version of your notes, right? And practice, practice, practice. You have your answers, you have your explanation. Go back and redo all the questions, okay, all the examples, do them over, don't just read them. Right, take the blank copy and work out the questions for yourself. And I'm sure there's a quiz that follows this. Right, and I will see you in the next video.